through AMOC, article on what did the article say? क्या कह रहा है आर्टिकल? समझ में आया? What did it say? कौन से नॉर्थ में जाएगी? एमॉक कह रहा है कि इंडियन ओशन बिकॉज वो ज़्यादा वार्म है ड्यू टू द एब्सेंस ऑफ द कोल्ड करंट्स, therefore this becomes a low pressure belt as compared to the same latitudes of the other ocean. Because it is a low pressure belt, it will pull all the winds in this region and hence यहाँ पे there will be heavy rainfall. But because the winds are coming from the surrounding region, this will be dry. Because it will be dry, क्योंकि the winds from the Atlantic Ocean are pulled here, so the Atlantic Ocean will remain dry, Pacific will also remain dry. Because it remains dry, there will be less rainfall, therefore increase in the salinity. Abhi saline water, you already know there is a thermohaline circulation. Saline water will sink, become denser, then it will rise as a cold current. Yahan pe Benguela current will increase. So yahan pe there will be more saline water which will go into the equatorial regions, and equatorial regions se it will go into the Gulf Stream, and Gulf Stream से पूरा अटलांटिक ज़्यादा सलाइन हो जाएगा. अगर सैलिनिटी बहुत ज़्यादा इंक्रीज हो गई तो वी नेवर नो व्हाट आर द इम्प्लीकेशंस, व्हाट इट मे कॉज. सो दिस इज व्हाट इज द एमॉक सेइंग, अटलांटिक मेरिडोनियल ओशन करंट्स. पढ़ा था कि नहीं आर्टिकल? पढ़ो, उसको काट के रखो. यू नेवर नो, ये अगले साल ऐसा आ सकता है रिगार्डिंग द दिस थिंग. Yes, because of global warming, more evaporation, and due to frequency of El Nino like conditions increasing, coming with a greater intensity, one which should come with 7 years, it is now coming after every 2 to 3 years, and therefore El Nino means more dry conditions. More dry conditions means more salinity. ग्लेशियर्स मेल्टिंग हो रहा है तो वो नीचे की तरफ इम्पैक्ट है, बट सैलिनिटी बहुत ज़्यादा इवेपोरेशन ट्रॉपिक्स एंड सब ट्रॉपिक्स में हो रहा है. ग्लेशियर का इम्पैक्ट ज़्यादा नहीं दिख रहा है एज कम्पेयर टू द इंक्रीज इन द सैलिनिटी ऑफ द ओशंस. Secondly, salinity is increasing because of the changes in the landscape. We are making the river more powerful in the terms of erosion. It is carrying more silt. Salinity कहाँ से जा रही है oceans की? From the land itself. Impact will be more in the terms of salinity. Glacial melt का impact बहुत बाद में दिखेगा. उसका बहुत बाद में दिखेगा glacial melt का impact. And we were doing the winds in the tropics. So first I will quickly revise what is the trade wind. उसके बाद what you are going to write about the trade winds. The wind that starts from the subtropical high pressure belt of 30 to 35 and goes towards the 0 to 5 degree longitudes, latitudes, 30 to 35 north and 30 to 35 south. So this is the wind that flows from high pressure to low pressure, and it is a warm wind. How does it flow? It flows from northeast to southwest in the northern hemisphere, and from southeast to northwest in the southern hemisphere. Over the period of time it gets heated, and therefore after coming at the equator region, it comes and it rises upwards. Therefore this region is known as ITCZ. The general direction of this wind is from east to west, and therefore we will call this as easterlies. यहाँ तक समझ में आया? Even if you have not studied that, यहाँ तक समझ में आया? These are known as easterlies. The easterlies, when they flow, they increase the moisture content and ocean temperature on the western part of the oceans or the eastern part of the continents. I am repeating again. The easterlies, when they flow, they increase the temperature of the oceans as well as moisture content. कहाँ पे? On the eastern part of the oceans or the western part of the continents. While the easterlies reduce the ocean temperature and increase aridity in the western part of the continents or the eastern part of the oceans. ये पढ़ा था उस बुक में, है mentioned कि नहीं है? मैंने पढ़ा नहीं हूँ. Is it there? But even if it is not there, listen to what I am saying. This is my continent, side view. This is the ocean. This is another continent. This is how the easterly is flowing from east to west. As it is flowing from, that is why it is known as easterly, the side view, top view. As it is flowing from east to west, it is offshore in this region, so it will remove the surface water. As it removes the surface water, there will be upwelling of cold current, and thus there will be cold water. So easterlies reduce the temperature in the eastern part of the oceans or the western part of the continents. Because of the cold currents, it will discourage evaporation, and therefore यहाँ पे will find deserts. On the other hand, it will result into piling up of surface water here, which will be warm water. And because of the piling up of the surface water, it will increase the temperature. Increase of the temperature may result into warm ocean currents or tropical cyclones or even the normal kind of an rainfall. Right? Understood this? So what we generally see in the easterlies, जहाँ पे if we draw a continent, we see in the easterlies somewhat like this. If this is our imaginary continent, in the zone of easterlies, we find कि जहाँ पे easterlies is coming from sea to land, onshore, middle of the land, and from land to sea, offshore. So which is offshore? This region is offshore. Which is onshore? This region is onshore. So it comes inside, brings the moisture from the sea. Already the sea is hot, upar, and therefore there is greater amount of evaporation. As it comes here, it will result into the formation of clouds, and it will give the rainfall. जैसे अंदर जाएंगे, the amount of moisture will decrease, and therefore the amount of rainfall will go on decreasing. Fine? And फिर से अंदर there will be no new moisture because wind will get moisture. मतलब जेट स्ट्रीम और मॉनसून शुरू करने से पहले आज मैं पोटेंशियल इवेपोट्रांसपिरेशन, ह्यूमिडिटी वो सब करूँगा, एंड देन वी विल स्लाइटली गो ऑफ द टारगेट कि ये जो मेन कंसेप्ट से पहले हम कर लेंगे, एंड उसके बाद हम एप्लीकेशन करेंगे जेट स्ट्रीम्स, मॉनसून, साइक्लोन्स एक्सेट्रा. तो एज इट गोज इनसाइड द टेम्परेचर फर्दर गोज ऑन डिक्रीजिंग, एंड यहाँ पे बहुत कम बारिश या बारिश नहीं होती, एंड देयरफॉर इन द ईस्टर्ली विंड बेल्ट देयर आर 3 टिपिकल रीजन्स. दिस रीजन जहाँ पे रेनफॉल होता है थ्रू आउट द ईयर इज द रीजन, या रेनफॉल होता है व्हेनेवर देयर इज अ ईस्टर्ली विंड कमिंग ऑन शोर, इज द रीजन ऑफ deciduous forest. And because we are doing the tropics, this is a tropical deciduous forest. जिसको कभी कभी कहते हैं मॉनसून टाइप ऑफ फॉरेस्ट। जैसे हम अंदर जाएंगे, द ट्रीज विल बिकम शॉर्टर और द ट्रीज विल बी रिप्लेस्ड बाय ग्रासेस बिकॉज रेनफॉल हैज डिक्रीज्ड एंड द हीट हैज इंक्रीज्ड एंड देयरफॉर यहाँ पे देयर विल बी ट्रॉपिकल ग्रासलैंड्स और सवाना। एंड जैसे और अंदर जाएंगे ऑन द वेस्टर्न पार्ट ऑफ द कॉन्टिनेंट्स, grasses will ultimately disappear and there will be only the shafts of the grasses, उनको भी कांटे होंगे, xerophytic vegetation, and this is the tropical deserts or hot deserts or trade wind desert. So this is the most important concept which should be seen in the answer regarding the winds in the tropics. So winds in the tropics, that is the trade wind, because of its onshore and offshore nature, gives rise to 3 different type of climatic zones. Monsoon, always on the eastern coast of the continents. Fine. Savanna in the middle of the continents, and always on the western coast of the continents we have the deserts. Is it true for India? If I take India, this entire is the monsoon lands of Asia. Is it not the eastern coast of Asia? उसके बाद थोड़ा बहुत सवाना टाइप ऑफ ग्रासलैंड्स एंड उसके बाद ये पूरा डेजर्ट है. यहाँ तक एशिया है, याद रखना. वी आर एक्चुअली ऑन द ईस्टर्न साइड ऑफ द एशिया. थोड़ा बहुत हम साउथ ईस्ट की तरफ है, बट वी कॉल आवर सेल्फ एज साउथ एशिया टू डिस्टिंग्विश फ्रॉम दिस कल्चर. बट दिस इज द मानसून. Only monsoon is not here. Monsoon is in all this region on the eastern side of the Asia. Getting it? Winds in the tropics. So open the handout of yesterday. You can take the handout from there. I will give you. Can someone tell me the page number? 140. Winds in the tropics. Cancel the first paragraph, not required. I guess I have already told you all this. Trade winds, 116. The trade winds which move out from the subtropical high pressure belt towards the equator. This is the first point. लिखने की ज़रूरत नहीं, has to cover a longer distance, etc. In the different sections of their path, conditions of temperature, humidity and density are not uniform. Obviously, the condition of temperature, humidity, density will keep on changing. दिख रहे हैं यहाँ पे? It may be noted that on the eastern side of the subtropical anticyclones, the trade winds are dry, and here the subsidence of the air currents is very, very strong. I'll explain you what is that point. Subtropical anticyclones, horse latitudes. This is the region. कभी-कभी subtropical anticyclones, that is horse latitude, is present during between 25 to 35 degree north and south. 30 to 35 तो actual position है, but pressure belts will keep on shifting. And if the subtropical anticyclones develop, तो this becomes the eastern side of the subtropical anticyclone, and दूसरे ocean में that becomes the western side of the subtropical anticyclone. Understanding the statement? अगर subtropical anticyclone यहाँ पे develop हुआ, तो which is the eastern side and which is the western side? Because यहाँ पे subsidence है. Not that important point, just that you should understand. Trade winds blowing over the oceans are characterized by greater degree of constancy than on any other planetary wind in the world. Westerlies properly constantly develop nahi hoti. Why? Remember the pressure belts wala lecture, because the subpolar low pressure belt will keep on appearing and disappearing. It is constant only over Azores, Aleutian low and Icelandic low. बाकी के जगह नहीं है. So the winds भी नहीं रहेंगी. Remember, Aleutian low गायब हो जाएगा. Aleutian low will be there in northern hemisphere and Greenland or Icelandic low will be there. बाकी के सब जगह high pressure होगा. The wind will never flow from high to high. High to high. Wind always flows from high to low. ITCZ permanent है. Subtropical high pressure belt permanent है. So इन दोनों के बीच की wind is more or less constant. Westerly is not constant. Trade wind is always found over the India. सिर्फ direction change कर लेती है. कभी north east बनती है, कभी south west बनती है. But westerlies is found over India only during the winters, because वो constantly blow ही नहीं कर सकती. When it comes to India during the winters, we call westerlies as western disturbances. Next paragraph, बाकी का things are not required for exam. You can cancel all this, the rest of the things. Like other atmospheric motions, there are irregularities in the movement of the trade winds. मतलब though this is most regular, इसमें भी थोड़े बहुत changes है as per their motion. See, trade winds are the most constant winds of the world. इसीलिए they used to help in the movement of the ships, and they are known as trade winds. In the coastal regions, the areas, बाकी का मैं छोड़ रहा हूँ, in the coastal region areas, these winds are influenced by land and sea breeze. Besides, the seasonal migration of the wind belts also bring out seasonal variations in the trade winds. Example वहाँ लिख लो, southwest monsoon and northeast monsoon. ITCZ is a wind belt. It will keep on migrating up and down. When it migrates to India, southwest monsoon. When it migrates down from India, northeast monsoon. Everyone is following? If you don't have a background, ask me. Following it? Next paragraph पूरा skip करना है and come directly to the next page. There are spatial as well as temporal variations in the depth of the trade winds. Average depth is estimated to be between 1 kilometers to 3 kilometers depth of a trade wind. कितना thick है? The depth of this winds in the vicinity of subtropical high pressure belt and towards the depth of this winds in the vicinity of subtropical high pressure belt and towards the equatorial regions where they converge with their counterparts from other atmosphere is very large. Underline this is very good point. It should come in exam. इसका मतलब है कि in this belt of the trade winds, there are two belts. If you remember the tricellular meridional circulation. One belt is the equatorial belt. One belt is the subtropical high pressure belt. Thickness of the trade winds मतलब depth. कहाँ पे ज़्यादा है? Either in the equatorial belt or in the subtropical high pressure belt. Right? Getting it? क्यों? Simple fact. यहाँ पे subsidence हो रहा है, then it is flowing at the surface, और यहाँ पे आके ऊपर उठ रही है. So यहाँ this is a thick area, this is a thick area, ITCZ. बाकी के जगह it is flowing only as the surface winds. So where is the depth greater? Either where the wind is going upwards or either where the wind is coming downwards. Understanding this point? Everyone? समझ में आया? वर्टिकल टेम्परेचर डिस्ट्रीब्यूशन, बाकी का कुछ काम करिए. The vertical distribution of temperature in the trade has certain general characteristics. Over the oceans, the lapse rate is very steep in the lower part of the winds up to the height of 600 meters. This is so because of the cold air coming in contact with the warm ocean surface is heated from below. Fractocumulus clouds form over the moist and turbulent lower layers of the atmosphere, of the air. These clouds are known as trade cumulus. From the top of this turbulent layer, the lapse rate decreases upwards. Tell me, what does this statement mean? कुछ नहीं, बहुत ही सिंपल है, बट ये टेक्स्ट बुक है. लैंग्वेज हैज़ टू बी टफ. फॉर एग्जाम्पल, मैंने जो सैम्पल पेपर क्वेश्चंस, सैम्पल चैप्टर्स मैंने भेजे थे फॉर ऑक्सफोर्ड पब्लिकेशन, मीन्स आई एम राइटिंग अ बुक ऑन इंडियन ज्योग्राफी. अब पता नहीं हो कब कंप्लीट होगा, लुकिंग एट द शेड्यूल, बट आई हैड गिवन इन अ वेरी सिंपल लूसिड लैंग्वेज. तो फीडबैक इज मेक इट बिट कॉम्प्लेक्स. It should not look like notes, it should look like textbook. That is why ये language is bit tough. इसका मतलब ये है, trade, जहाँ पे the trade winds are blowing in the tropical oceans, ocean warm है because they are retaining the heat. Generally wind cold है, so इतनी thick wind when it is coming in this region, इतनी thick wind when it is coming in the region, warm oceans, cold winds, and इसीलिए lapse rate, decrease of temperature is very steep. बहुत सडनली से टेम्परेचर डिक्रीज हो रहा है. फाइन, बट उसके बाद टेम्परेचर थोड़ा धीरे धीरे से डिक्रीज हो रहा है बिकॉज ऊपर इतना ज़्यादा डिफरेंस ऑफ द टेम्परेचर नहीं. यहाँ पे द ग्रेटर डिफरेंस ऑफ द टेम्परेचर इज देयर बिकॉज वार्म ओशन सरफेस से कोल्ड विंड इज कमिंग इन कॉन्टैक्ट. देयर इज इवेपरेशन ऑल्सो and therefore the temperature continuously decreases. But after a certain layer, if you remember temperature inversion, the air is not a good conductor of heat and therefore ऊपर lapse rate ज़्यादा नहीं है. Now second point here is because this is warm and ऊपर का layer is colder, there is evaporation which is occurring from the warm surface, and because of this air ऊपर जाएगी and it will result into formation of clouds. What are these clouds known as? Cumulus clouds. Because they develop in the trade wind belt, they are known as trade cumulus clouds. समझ में आया? अब व्हाट इज अ क्यूमुलस क्लाउड? क्यूमुलस क्लाउड मतलब जिसका शेप ऐसा है, नथिंग एल्स. ऐसा क्यों है क्लाउड का शेप? बिकॉज ये इवेपोरेशन एंड कन्वेक्शनल हीटिंग से हुआ है. क्योंकि बाकी के क्लाउड्स का शेप ऐसे भी हो सकता है, स्ट्रेटस क्लाउड्स. कुछ क्लाउड्स का शेप ऐसे भी हो सकता है, सीरस क्लाउड्स. कुछ क्लाउड्स का शेप गोल होता है, that is cumulus clouds. Cumulus clouds signifies convectional heating. Convectional heating कहाँ होगा? In the warm wind belt या cold wind belt? Warm. So what is trade wind belt? Warm or cold? Warm. Therefore cumulus cloud बन रहे. Understanding? So that is the statement. Now I am reading it again. The vertical distribution of temperature in the trade wind has certain general characteristics. Over the oceans, the lapse rate is very steep. Lapse matlab decrease of temperature with increasing height is very steep in the lower parts of the wind up to the height of 600 meters. Understanding why the lapse rate is steep? Because this is warm, this is cold, cold, cold. This is so because the cold air coming in contact with the warm surface is heated from below. Fractocumulus clouds formed over the moist and turbulent lower layers of the air. As air will become warmer, it will become turbulent. Turbulent बनते ही वो convectionally ऊपर जाएगी and it will result into formation of cumulus clouds. These clouds are called as trade cumulus. From the top of this turbulent layer, the lapse rate decreases upwards. Cloud जब तक बना तब तक lapse rate बहुत ज़्यादा है. Cloud के बाद the lapse rate is going to decrease. Understood now? Over the heated continents, The lower layers of the trade winds record a very steep lapse rate during the daytime. Again the same thing is there. Continents अभी heated है, so lower layers के बीच temperature difference बहुत is very high, and therefore the lapse rate is very steep. Lapse rate is decrease of temperature with increasing height. Because of the lapse rate being very steep, अब क्या, which kind of inversion will occur? Mechanical inversion, in which the air will go upwards at a very high speed, up to a greater height, will cool adiabatically, and this cool air will come and subside and displace the warm air. So because of the trade wind inversion in the upper air, the dry air currents are not allowed to move up to a higher levels, so that no cloud formation takes place. Underline this statement is very important. Because of the inversion in the upper air, the dry air currents are not allowed to move up to a higher levels, because ऊपर जाके air has become colder. Cold air being denser, dry air cannot displace the cold air, warm air. Dry, warm air cannot displace the cold air, so that no cloud formation takes place. Besides, the rising air currents carry with them lot of dust particles, because what is there in the heated part of the continents? वो किसकी बात कर रहा है? Deserts की. That is why tropical deserts are characterized by clear sky, strong sunshine, cloud नहीं बनेगा, clear sky है, but also dust storms. Dust laden storm is nothing but dust storms. Understood? Understood? Ab I'll give some points regarding the trade winds, what you should be writing in the exam. This is the textbookish language. So we'll write some points regarding the trade winds. I am not dictating. Write the first point is regarding from where? From the subtropical high pressure belt to equatorial low pressure belt, and therefore known as equatorial low pressure belt, where they converge. Where they converge. And therefore, this region is known as ITCZ. Known as ITCZ. Second point. Understood? Due to the permanency of pressure belts, due to the permanency of pressure belts, the trade winds are comparatively more constant trade winds are comparatively more constant. Understanding the second point? Though there may be change in the space and direction. Though there may be change in the space and direction. This generally occurs, this change occurs due to shifting, this change occurs due to the shifting of pressure belts along with northward and southward movement of the sun. Understood? Next point. When the ITCZ, shifts to the foothills of the Himalayas, when the ITCZ shifts to the foothills of the Himalayas during summer solstice, during northern summer solstice, the trade winds of southern hemisphere, after crossing the equator, become southwesterly in direction, Flon had called such trade winds, southwesterly in direction, Flon had called such trade winds, F-L-O-H-N, Flon had called such trade winds as what? Equatorial westerlies. Trade winds as equatorial westerlies. Understood? Equatorial westerlies. Why? Because due to the Coriolis force, they change. You can draw this diagram. ये जो ब्लू लाइन है वहां पे वर्ल्ड में सबसे ज्यादा हीटिंग है, इतना याद रखो. दैट इज अ लो प्रेशर बेल्ट. इन सिंपल वर्ड्स, दिस इज द लो प्रेशर बेल्ट, जहां पे मैक्सिमम हीटिंग इज ऑकरिंग. Can I continue? Can I continue now? As per a school of thought in climatology, equatorial westerlies extend towards India as southwest monsoon winds. Extend towards India as the southwest monsoon winds. Extend towards India as southwest monsoon winds. As the southwest monsoon winds. Getting it? Next point. There is spatial, matlab as per space. There is spatial and temporal variations, matlab as per time. Time means seasons, month. Space means area, geography. And temporal variations in the pressure and temperature, in the pressure, temperature, and pressure, temperature, humidity and density of trade winds. Humidity and density of the trade winds. In the lower part of the trade winds, the lapse rate is very steep. Understood why? हमने टेक्स्ट में से देखा why. In the lower part of the trade winds, lapse rate is steep. Next point, मतलब उसी point का continuation है. The western part of the trade wind, the western part of the trade wind over the oceans, the western part of the trade winds over the oceans is moist and warm, while the eastern part is cold and dry. Eastern part is cold and dry due to difference in the ocean temperature. Clear? This is the point. एक part moist है, एक part fine. जहाँ पे cold currents है, it is moist, it is cold and dry. जहाँ पे warm currents है, it is moist and warm. Steep, that is steep lapse rate. Can I continue? This modification of air masses, अब एक विंड को मॉडिफाई कर दिया तो क्या बन गया? वो विंड नहीं रही, वो बन गया एयर मास, विच इज अ सेपरेट टॉपिक इटसेल्फ. सो एक जो रेड कलर का सर्कल है, दैट इज कोल्ड एंड ड्राई एयर मास. जो ब्लू कलर का सर्कल है, पर्पल कलर का सर्कल है, दैट इज मॉइस्ट एंड वार्म एयर मास. अंडरस्टैंडिंग? अब वो विंड नहीं रही, वो एयर मास हो गया. This modification of air masses gives rise to different biomes when warm and moist air mass is onshore. When the warm and the moist air mass is onshore. warm and moist air mass is onshore, it leads to the formation of deciduous biome, tropical deciduous biome. The cold and the offshore trade winds, the cold and the offshore trade winds gives rise to trade wind desert biome, trade wind desert biome. The zone of convergence of two different trades, zone of convergence of two different trades gives rise to tropical evergreen biome, क्योंकि रेनफॉल डेली हो रहा है, gives rise to tropical evergreen biome. While the transition zone between all these biomes देखो इसके नीचे ट्रॉपिकल एवरग्रीन फॉरेस्ट है, फाइन, इसके ईस्ट में डेसिडियस, वेस्ट में डेजर्ट, सो ये है ट्रांजिशन जोन, गिव्स राइज टू इथोपियन रेलिम और इथोपियन बायोम और सवाना बायोम. रेलिम जब हम ह्यूमन, बायोम इज ओनली नेचुरल, जब हम ह्यूमंस को कंसिडर करेंगे, ज्योग्राफी को कंसिडर करेंगे रेलिम, कल्चर को कंसिडर करेंगे रेलिम. Getting it? If you want to draw, you can draw this diagram. See, this how a complete answer regarding the trade winds. Different from the textbook, but we have taken main points from the textbook itself. But हमारा answer simple और diagrammatic ज़्यादा है. This is how you should be writing in the climate. इतना नहीं आएगा because इसके लिए आपको environment ecology भी पता होनी चाहिए, Ethiopian biome, relim, etc. Clear? Animal life will be different, everything will be different in these biomes. Technically our class is going on in a boundary of deciduous biome and the start of Ethiopian biome. Delhi, Haryana, Rajasthan, पाकिस्तान, अफगानिस्तान, अफगानिस्तान थोड़ा नॉर्थ में हो जाता है इसलिए ठंडी ज़्यादा है, बट ईरान, इथोपिया, सोमालिया ये सब सवाना ग्रासलैंड्स के जोन है. उसके बाजू में सऊदी अरेबिया, इराक एक्सेट्रा इज टोटली डेजर्ट. थार डेजर्ट इज एक्सेप्शन इन दिस पार्ट. Fine. Punjab is desert properly definition wise, but पानी इतना ज़्यादा है because it is a region of Doab, that is a land between rivers. Though rainfall is less, but it is a region of Doab and इसलिए feel नहीं होता because of the water. Climatologically अगर देखा गया तो पंजाब is a desert. राजस्थान के just ऊपर ही तो है, right? This has been asked as a question also. Ethiopian relief. But this is 5th chapter. Fine? Equatorial westerlies. You already know everything. Tell me what you are going to write. 200 words, 150 words. चलो उसको expand कर पाओगे diagram के साथ 200 words में. What are equatorial westerlies? What is equatorial westerly? Words, 200 words. This is what is the equatorial westerlies. Last year there was a question. Write a short note on equatorial westerlies. First question. Paper 1 का question number 1 में B. मतलब वैसे technically second question of your paper. 150 words. क्या लिखोगे? कुछ नहीं, mechanism. क्यों ITCZ shift होगा? उससे क्या होगा? फिर फ्लॉन का नाम. फिर इक्वेटोरियल वेस्टर्लीज क्यों बहती है, कहाँ पे, किस रीजन में. ITCZ पूरे वर्ल्ड में शिफ्ट होता है या ओनली इन द इंडियन ओशन इतना प्रोमिनेंटली शिफ्ट होता है? इट इज ओनली इन द इंडियन ओशन इट प्रोमिनेंटली शिफ्ट्स. व्हाई ओनली इन द इंडियन ओशन? बिकॉज ऑफ द हीटिंग ऑफ द टिबेटियन प्लाटू. बाकी वर्ल्ड में देयर इज नो लैंड मास सो हाई कि ITCZ टू शिफ्ट. फाइन. बाकी ओशंस में देयर इज कोल्ड करंट ऑन दिस साइड, सो इट डज नॉट बिकम वार्म. हेंस कहाँ से कहाँ तक जाती है इक्वेटोरियल वेस्टर्लीज? फ्रॉम अफ्रीका टू वेस्ट पैसिफिक. फिर वो एग्जैक्टली वेस्ट टू ईस्ट जाती है या साउथ वेस्ट टू नॉर्थ ईस्ट जाती है? साउथ वेस्ट टू नॉर्थ ईस्ट. इसलिए कुछ लोगों का कहना है कि दिस इज द नथिंग बट मॉनसून विंड्स ओनली. परमानेंट है या सीजनल है? सो दे आर सीजनल. दे आर फाउंड ओनली इन द समर सीजन. गेटिंग इट? सो दिस ऑल बैकग्राउंड यू हैव टू गिव while writing the answer, and the name of a climatologist that should come is Flon. Flon had discovered, Fetcher and Flon had discovered, but Flon is more important. Fine? An equatorial westerly is one such thing. If you like searching on the net, you can search on the net for the equatorial westerlies. Getting it? So equatorial westerlies. Generally the air circulation is very feeble. and weak in the zone of ITCZ. In the zone of ITCZ. On an average, the air circulation sometimes the air circulation in this belt, becomes west to east, in the regions of around 200-degree longitudes, latitudes नहीं, longitudes, not latitudes. Indian Ocean से Pacific Ocean, 200-degree longitudes. This weak westerly winds are known as equatorial westerlies. You can draw the diagram. Trade winds of the southern hemisphere, trade winds of the northern hemisphere, ITCZ पे आके they will go up. ITCZ is between 0 to 5 degree north, 0 to 5 degree south. So north ITCZ, south ITCZ. उन दोनों के बीच the wind is flowing from west to east. And this is the equatorial westerlies. Is it due to the rotation of the earth? No. Rotation of the earth के कारण wind cannot flow in the same direction. डायग्राम प्रॉपर्ली बनाओ, मेरा आज पेन डिफेक्टिव है, सो अदरवाइज फाइन. कैन आई कंटिन्यू दिस? बट ऐसा नहीं है जो हम अभी लिखेंगे, शिफ्ट करूंगा. द कंसेप्ट वाज डिस्कवर्ड बाय Flohn, F-L-O-H-N, Flohn, who maintained that the southwest monsoon of Asia are equatorial westerlies. Maintain that southwest monsoon of Asia are equatorial westerlies. Mechanism, but Flohn galat tha totally. Mechanism, during the northward shift of the sun, the low pressure equatorial trough another name for ITCZ, low pressure equatorial trough, extends up to India, low pressure equatorial trough, 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 extends up to India. The extension of this trough is due to thermal heating. The extension of this trough is due to thermal heating and the position of sun. Getting it? Due to this, the trade winds from the southern hemisphere, which are easterly in direction, cross the equator, full stop. After crossing the equator, they get deflected to the right. After crossing the equator, they get deflected to the right and become either southwesterly or westerly, depending upon the temperature conditions in the Indian Ocean. The southwesterly winds come towards India as monsoon, while the westerly winds proceed towards Southeast Asia and South China Sea region. Proceeds over Southeast Asia and the South China Sea region. Full stop. Therefore, the zone of equatorial westerly Therefore, the zone of the equatorial westerlies is between West Africa and East Africa and Western Pacific. It's between East Africa and the Western Pacific. Recent observations have shown that during the positive phase of Indian Ocean dipole, the equatorial westerlies become weak. Oh, I'm so sorry. Yeah, the equatorial westerlies become weak. Understand this diagram. Indian Ocean dipole means two parts of the Indian Ocean, western pole, eastern pole. Fine. So during the positive phase, western pole Arabian Sea is more warmer, eastern pole is more cooler. As the law of the wind says, the wind flows from high pressure to low pressure. This is how the wind will be flowing. So can I say westerlies become weak or strong? Weak, because wind is now moving from east to west. Westerly should move from west to east. Fine? Full stop ke baad. But during the negative phase of Indian Ocean dipole, the westerlies blow with great intensity. From cooler Arabian Sea towards warmer Indonesia region. Cooler Arabian Sea towards the warmer Indonesia region, weakening the Indian monsoon or reducing the monsoon rains over India. And you can draw this diagram. Understanding this? High pressure to low pressure. High pressure जहाँ ठंडा है, blue color. Low pressure जहाँ गर्म है. यहाँ पे इवेपोरेशन ही नहीं हो रहा है, सो ये विंड्स ड्राई रहेगी जो इंडिया के पास से जाएगी. जीएस के लिए भी समझ में आया व्हाट इज पॉजिटिव एंड नेगेटिव फेज ऑफ इंडियन ओशन डायपोल. नेगेटिव मीन्स हमारे लिए नेगेटिव. हमारे लिए कब नेगेटिव रहेगा? व्हेन दिस इज कोल्ड एंड दिस इज वार्म. हमारे लिए कब पॉजिटिव रहेगा? व्हेन दिस इज वार्म एंड दिस इज कोल्ड. सो दैट winds will come towards India from southern hemisphere. After crossing they will come towards India. वो नहीं समझ में आया किसी को. कब बनता है अल नीनो? फिर भी पता है कैसे बनता है. इंडियन ओशन डायपोल कैसे बनता है नहीं पता है. अल नीनो का पैटर्न भी पता है कि हर 7 साल बाद या 3 साल बाद रिपीट होगा. ये कभी भी आता है. न्यूट्रल क्यों है, नेगेटिव क्यों है, पॉजिटिव क्यों है, ये अभी तक नहीं समझ में आया. 2 चीज़ें जो अभी तक समझ में नहीं आई है वो है मैडन जूलियन ऑसिलेशन. हमें पता है उनसे क्या होने वाला है. वी नो द इम्पैक्ट्स ऑफ दिस, व्हाट इट विल डू, बट वी डोंट नो व्हाट इज द कॉज बिहाइंड दिस. फ्लॉन का कंसेप्ट गलत था ना. ये है रिसेंट. Monsoon is not just over India. Monsoon is over entire Asia. यहाँ पे monsoon rain हो रहा है during the negative Indian Ocean dipole. During the negative Indian Ocean dipole, rainfall is occurring over Indonesia, Malaysia. Droughts over India. During the positive Indian Ocean dipole, rainfall is occurring over India. Droughts in this region. क्योंकि wind circulation is from east to west. फ्लॉन ने सिर्फ इसी को कंसिडर किया था, इक्वेटोरियल वेस्टर्लीज. इसलिए वो जो स्टेटमेंट दिया है कि दे आर कंटिन्यूएशन ऑफ ट्रेड विंड्स, तब फ्लॉन का नाम आना चाहिए. इट इज नॉट एक्सेप्टेड. इट वाज सेड ओनली बाय फ्लॉन. That is why I did not ask you to make that diagram. That is just for your understanding. जो मानसून है. See, if the equatorial westerlies are stronger, see this is the normal condition of Indian monsoon. If the equatorial westerlies are stronger, वो ऐसे जाएगी. Indian monsoon के लिए it has to be southwest. Not just westerly. Can I continue? Conclusion. The pattern and the impact of equatorial westerlies is controversial. Pattern and the impact of the equatorial westerlies is controversial due to lack of agreement. Due to lack of agreement between the climatologists. देखो लैक ऑफ एग्रीमेंट कितना बड़ा है. जनरल क्लाइमेटोलॉजिस्ट इसको कहते हैं डोल्ड्रम्स, विंड्स ही नहीं है. कुछ क्लाइमेटोलॉजिस्ट कहते हैं कि इसमें इक्वेटोरियल वेस्टर्लीज है. दोनों कैसे हो सकता है एक साथ? एक तो डोल्ड्रम का बेल्ट है, इक्वेटोरियल वेस्टर्लीज का बेल्ट है. इट कैन नॉट बी बोथ. बट व्हाट वी जनरली प्रिस्क्राइब और स्टडी is the dominant view. So the dominant view is doldrums. What you study? Doldrum, belt of calm, winds है तो how there can be calm conditions. इसीलिए इन सविंद्र सिंह या इन DS लाल और एनी बुक ऑफ क्लाइमेटोलॉजी जो आपके टेलीग्राम ग्रुप पे भी है, देयर इज नो मेंशन. इंडियन बुक्स में थोड़ा बहुत मेंशन है, फॉरेन बुक्स में मेंशन ही नहीं है इक्वेटोरियल वेस्टर्लीज का, बिकॉज इट इज अ जस्ट लाइक आइसोस्टेसी, ओल्ड कंसेप्ट है, कैंसल्ड है. फ्लॉन ने दिया था 1902 में, nobody accepts it now. Fine? He had given in 1902. If there is equatorial westerly, then why tropical cyclones move from east to west? They should move from west to east. That is the controversy. This is how the climatologists ask the proponents or the people who support the equatorial westerlies. Tropical cyclone will always move in the direction of wind. So if you are saying there is equatorial westerlies, then why the tropical cyclones move from east to west? Clear? Again, we'll do the same thing. We'll read first and then write in the simple language. Between the latitudes 25 to 35 degrees, Mila, subtropical winds. Within the subtropical high pressure belt, there are large elliptical high pressure cells over the oceans. They represent anticyclonic conditions. These oceanic high pressure cells play a very significant role in the general circulation of the atmosphere. What does it mean? Ki, this statement simply means that high pressure cells are actively formed, permanently formed over the oceans. They may or may not be formed due to land, on the land. Why? Because high pressure means where the air subsides, comes down. There is aridity, there is lack of moisture, but you have just seen why it cannot be permanently on the land, because though it is between 25 to 35 degree latitude, यहाँ पे monsoon की winds है. Though it is between 25 to 35 degree latitude, it is a tropical deciduous forest. And there, ये सिर्फ oceans पे है, permanent. Getting it? High pressure cells. Why? Because on the land it depends upon numerous factors, orography, mountains, absence of mountains, where there will be rainfall or not. It just does not depend upon descent or ascent. Fine? It has already been discussed, we have also done this, that these high pressure cells are dynamically produced by the subsidence of air in these latitudes. We have already discussed, air from the equator rises and subsides there. However, recent observations ascribe their origin to the upper westerlies and the jet streams. It is from these subsidence zones that the westerlies and the trade winds originate. Between the two opposing wind systems, there is a belt of calm, which is also known as horse latitudes. So there are two belts of calm. One is the belt of doldrums and the other is the horse latitude. Only difference is, not optional, GS. The only difference is, belt of calm in the equatorial regions is the rainfall wala belt. Belt of calm in the horse latitude is the desert wala belt. Remember this. In the ITCZ, there is a belt of calm, but the air is rising upwards. And because the air is rising upwards, it will give rainfall. In the horse latitude, there is a belt of calm, because the air is subsiding. One is flowing towards the equator as trade winds. One is going this way as westerlies. Fine? Because of the subsidence, this zone is characterized by clear and dry weather. In central region of the anticyclones, the winds are light and variable. There being greater subsidence in the eastern sector of the subtropical high pressure cell, the atmosphere remains dry. Why greater subsidence? We have just seen because of the cold currents. परसों का क्वेश्चन, ocean currents and water masses. Water masses is upwelling, downwelling. What is the impact of upwelling and downwelling? This is a water mass. Ocean currents, water mass, upwelling, more biodiversity, downwelling, less biodiversity. यही था क्वेश्चन in GS1. There is an inversion layer in the atmosphere which is not favorable for condensation to take place, not that important. On the account of these regions, all the hot deserts of the world are found on the western margins of the continents between 20 to 30 degree latitudes. Why? Because the eastern part of the anticyclone is dry, eastern part of the ocean is dry. Let's see how the textbook has connected. Textbook first told you that high pressure cells are regular only over the oceans. फिर कहा हाई प्रेशर सेल एंटीसाइक्लोन है. एंटीसाइक्लोन मतलब जहाँ से एयर सबसाइड कर रही है. Where the air is subsiding more, the part which is more cold, and that is the eastern part of the oceans, and therefore western part of the continents or the eastern part of the oceans. Same is the region of hot deserts. Deserts cannot be on the oceans, therefore continents. The Sahara, Kalahari and the Great Desert of Australia all have got similar locations. On the western side of the subtropical anticyclone, air is warm and moist. There is instability in the air in this part. The conditions described above are conducive to heavy precipitation. Such areas are situated on the eastern margin of the continents and the climates of the Gulf region, Caribbean Sea, eastern China, Japan, southeastern Brazil, southeastern Africa, eastern Australia reflect the conditions described above. See all these conditions, मैंने जानबूझ के पढ़ा, it has nothing to do with our topic. Can you understand the language? All these regions are the regions of warm ocean currents and therefore typhoons, cyclones as well as willy-willies. So इसलिए how is the condition? Condition is always moist. अब हमारा काम, westerlies, they blow between 35 to 60 or 65 degree north and south in both the hemisphere. The westerlies blow from horse latitude towards the subpolar low pressure belt in each hemisphere. The poleward boundary of westerlies often fluctuate with the seasons. I'll explain you why. But this boundary changes its position over the short period of times also. Westerlies are highly variable winds blowing at times with very high force, which is known as gale force. And other times they are gentle as a mild breeze. In the westerly wind belt, winds blow from all directions. ये क्यों लिखा है? Winds blow from all directions in the westerly wind belt. Because in the westerly wind belt there are warm ocean currents, creates a low pressure and it pulls winds from all the directions. Westerly wind belt is generally the zone of contact. Subpolar low pressure belt is the zone of contact of polar easterlies and westerlies fronts. So during the winter season, easterlies थोड़ी आगे बढ़ती है. During the summer season, westerlies थोड़ी आगे बढ़ती है. इसीलिए the poleward region of the westerly always fluctuates. Understanding that line? During the winter season, which wind is stronger? The polar easterly is stronger. It will be more dominant. During the summer season, which wind is stronger? Westerly is stronger. So कभी ये boundary हो जाती है, कभी ये boundary हो जाती है. A large number of traveling cyclones and anticyclones make the weather in this belt highly variable. Remember, this belt is the belt of fronts, and fronts are the regions of temperate cyclone. So यहाँ पे when he is referring to the cyclone, he is talking about temperate cyclone, not tropical cyclone. You have got in the subtropics. Subtropics में कभी भी tropical cyclone नहीं होंगे. Sudden changes in the weather is another important characteristics of westerlies. with this month, India has started coming under the influence of westerlies, and you will see suddenly the climate will keep on changing. It will become very variable. ये है westerlies. Westerlies आना शुरू हो गए इंडिया में, because pressure belt are shifting southwards. So North India is a subtropical or warm temperate zone. मतलब it is a transition zone between 25 to 35. Original position of westerly horse latitude 30 to 35. When the sun is in the southern hemisphere or at the equator, original position 25 to 35. So we are in that belt now, and therefore sudden climate change हो गया. Cross the tropic of Cancer, go to peninsular India, वहाँ बहुत ज़्यादा गर्मी होगी. There will be same type of climate, but North India में variation, because you are now under the westerlies. Peninsular India will never come under the westerlies, and इसीलिए वहाँ पे कभी भी ठंडी नहीं होगी, because trade winds are always warm. Understanding? However, the sequence of weather and the winds at a particular situation depends on its location with reference to moving temperate cyclone. I'll later on, जब हम temperate cyclone करेंगे, you will understand this. I have already done in GS. They know, maybe basically know this. This is how the temperate cyclone is. This entire area, मैं cross sectional view दे रहा हूँ. Warm front, cold front, यहाँ पे nimbostratus cloud and light rainfall, यहाँ पे cumulonimbus cloud and very heavy rainfall, यहाँ पे ground पे there is a cold air, यहाँ पे ground पे there is a cold air, यहाँ पे ground पे there is a warm air. This warm air is rising upwards, this warm air is rising upwards. Fine. And this entire phenomena is moving from west to east. This is what is the temperate cyclone. Very different from yesterday what we saw the tropical cyclone. And इसीलिए ये line कहती है that the sequence of the weather and winds at a particular station, whether the station is A, the station is B, the station is C, station is D, station is E, सब में weather अलग है, and depends on its location with reference to moving cyclone. So if the station is A, right now it is having a cold climate. After some time, because it is moving from west to east, it will start getting the rainfall. Then the station A will have warm climate. Then the station A again will have very heavy rainfall, and again it will have cold climate, because the cyclone is moving from west to east. Understanding? Everyone? समझ में आया? In the northern hemisphere, the dominance of the land makes the wind system in westerlies more complex. You already know. Wind system complex होगा in the northern hemisphere because mountains है, ये है, वो है. Seasonal variation in the temperature and pressure over huge land masses is the main factor causing seasonal variation in the direction and the strength of the winds. In winter, the easterlies are far more vigorous than in summers. In winter, the easterlies are far more vigorous than in summers. Is there a typing mistake or is it a right statement? Yeah, they are talking about polar easterly winds. They are more vigorous in the winters, जो मैं यहाँ पे कह रहा था. In this situation, I was telling you the same thing. Next. During the winter season, the poleward boundary of the westerlies in the vicinity of the subpolar trough of low pressure experiences great thirst of polar air. It is here that the great polar air masses moving equatorwards clash with relatively warm air masses of the low latitudes. This results into creation of polar fronts. इसका कहना है कि whenever there is poleward part of the westerlies, westerlies will collide with the polar easterlies, and it will result into formation of a sloping boundary that is known as fronts. Along these fronts are born most of the extratropical disturbances, which is another name for temperate cyclone, which characterize the climate of this zone. The weather along the poleward margin of the westerly is therefore stormiest of all the regions in the world. Why stormiest? Because of the continuous clash of the winds. The condition in the belt of westerlies in the southern hemisphere are altogether different. There being a large percentage of water surface, the westerlies blow with full force without any interruption. Full stop. Continue writing uske aage. Therefore, they are known by different names, such as furious 50s, roaring 40s, furious 50s, and shrieking 60s. Roaring 40s, furious 50s, and shrieking 60s. At different latitudes. Westerlies is easy. Trade winds जैसा dictate करने की ज़रूरत नहीं, I guess. You will be able to write. Dictate करो. Chalo, you take points, some points. The winds that flow from subtropical high pressure belt subtropical high pressure belt to the subpolar low pressure belt in general from southwest to northeast in northern hemisphere, and from northwest to southeast, so from northwest to southeast in southern hemisphere are known as westerlies. एग्जाम में whenever you get confused, खुद डायग्राम बनाओ और डायरेक्शन लिखो. Fine? Northern and southern hemisphere are known as westerlies. Next, they originate as warm winds. They originate as warm winds. But after reaching the higher latitudes, they converge with cold polar easterlies. To form polar fronts. Frontogenesis frontogenesis. मतलब origin of fronts. Genesis is origin. Causes formation of temperate cyclones. Which under the influence of westerlies, move from west to east, Significance of westerlies? No, before significance, one more point. The westerlies in the southern hemisphere are more constant and due to the lack of land mass, bracket में thus reducing the frictional force, flow with great speed, great speed, या टेक्निकली लिखना है तो जब विंड की स्पीड 80 किलोमीटर पर आवर के ऊपर से हो जाती है, देन इट इज नोन एज गेल फोर्स. And are known as roaring 40s, furious 50s, shrieking 60s. Roaring 40s, furious 50s and shrieking 60s. Roaring 40s, furious 50s, shrieking 60s. Getting it? The speed of the westerlies is more during the winters. The speed of the westerlies is more during the winters. क्यों? बताओ. Because subpolar regions become extremely cold. Fine? And because subpolar regions, the subtropical high pressure belt 30 to 35 winters में ठंडे हो जाते हैं. This region becomes cold, so high pressure increases. And वहाँ पे subpolar low pressure belt में low pressure और intensify हो जाता है. क्यों और intensify हो जाता है? Because polar wind which start during the winters at minus 40 degrees Celsius. Summers में तो they will start at minus 10 or 0 degrees Celsius. But when they start at minus 40 degrees Celsius, आते आते वो subpolar low pressure belt में comparatively they become more warmer. And therefore they start descending more. As they start descending more, low pressure is getting intensified. So greater the difference between the pressure belts, high pressure and low pressure, the speed will increase. Understanding? Summers में what happens? Low pressure is not intense because this belt 30 to 35 degree latitude जो है, जहाँ पे हम है अभी, यहाँ पे summer temperature is around 40-45, but winter temperature यहाँ पे हो जाता है 5 degrees Celsius. So when is the high pressure belt more? Winters. Greater the difference between high pressure and low pressure, greater will be the intensity. Fine? Become more intense during the winters. Making the temperate cyclones more continuous more continuous and powerful and powerful. Fine. Significance अब significance. See, इस पॉइंट से मेरे को कल किसी ने GS बैच में इनसाइट की एक टेस्ट सीरीज का क्वेश्चन दिखाया. He was asking a doubt. I told him the reason. The question was, in the higher latitudes, in the middle and the higher latitudes, sea waves are more stronger during the winters. True or false? बहुत ही applied. In the middle and higher latitudes, sea waves are more stronger during the winters. Yes, sea waves are caused due to winds. Waves are caused due to winds, and winters में winds are more speed, more stronger. Therefore, waves की speed, waves ज़्यादा ये होंगे. देख, very good question. Fine. So trade winds का effect है ये. NCERT में दिया है and past year question भी है ये. The waves are more powerful in southern hemisphere as compared to northern hemisphere. Yes, wind, southern hemisphere में winds are more faster because frictional force कम है and therefore waves are much higher. Getting it? So ऐसे applied questions भी oceanography को सब आप solve कर सकते हो अभी MCQs. Right? कुछ doubts है तो you can ask me. Don't wait for your GS to get over. जो हमारा पोर्शन हो रहा है ऑप्शनल में उसके MCQs सॉल्व करो. (18 to 23 क्वेश्चंस में your strike rate should be, you are going to clear the prelims. जो तुम्हारा ऑप्शनल है उसमें सबसे ज़्यादा राइट होने चाहिए. If your optional is geography, क्वेश्चंस आते हैं 23 and आपके हैं 15 राइट, you are wrong. It should be 20 minimum. Geography, environment, agriculture मिला के इस साल के पेपर में 26 क्वेश्चंस है. तो environment तुम्हारा 4th and 5th chapter is environment of paper 1. The 8th chapter of paper 2 is social issues. Demography, demographic transition model, land border management, caste system. Fine. Chapter number 2 and 3 is totally agriculture and resources. 2012 से पहले भी environment से question आते थे 7-8 हर साल. तब तो syllabus में environment नहीं था. What is environment? As part of geography जिसको separate करके थोड़ा और detail में कर दिया UPSC. Environment तो पहले से है. ऐसा तो नहीं है कि चैप्टर 4 and 5 that is environment and biodiversity has been added recently. So environment should be your very strong point. Entire chapter 4 and 5 is your optional. That is environment. Paper 2, chapter 2 resources. Water stress क्या है, ये सब क्या है, water resources, agriculture. Chapter 3 agriculture. Chapter 5 cultural diversity of India, social issues. Where did I stop? Significance. First significance of westerlies. They increase the temperature on the western coast of the continents. They increase the temperature on the western coast of the continents in the higher latitudes. In the higher latitudes. Because they carry warm ocean currents. Warm ocean currents. Fine. Gulf Stream को कौन लेके जा रहा है? As a North Atlantic drift, westerlies, giving rise to West European type of climate. giving rise to West European type of climate. Second, westerly drive the temperate cyclones. Westerlies drive the temperate cyclones from west to east. From west to east. And this temperate cyclones give rain, give precipitation. Summers में rainfall, winters में snowfall, इसलिए we are using the word precipitation. In the interiors of the continent, throughout the year, giving rise to boreal biome. Boreal biome मतलब taiga. Fine. See, when I say 23 to 27 question in prelims, and लोग जब कहते हैं ज्योग्राफी में से क्वेश्चंस नहीं आते, यू शुड चेक, क्रॉस चेक द सिलेबस. इसका कहना यह है कि चाहे वो जीएस में पढ़ाया गया एज अ सोशल इशू, चाहे वो जीएस में पढ़ाया गया एज अ इकोनॉमिक्स, आपके जो ऑप्शनल के सिलेबस में है इरिगेशन सिस्टम्स, आपके ऑप्शनल के सिलेबस में है एमएसपी, दो इन जीएस पेपर 3 इट इज इन इकोनॉमिक्स टीचर विल टीच यू, बट यहाँ पे एज अ ज्योग्राफी ऑप्शनल स्टूडेंट यू आर गोइंग टू रीड एवरीथिंग. यू शुड बी डूइंग एग्रीकल्चर चैप्टर फ्रॉम द इकोनॉमिक सर्वे. सो ये सब मिला के that comes this year there are 27 questions. मतलब इतना ज़्यादा हो रहा था कि when I discussed the paper मैंने बोला बस ऐसे बच्चों को लगेगा ये सब ज्योग्राफी से है, तो I discussed only 23 questions. बाकी के social capital directly as it is geography optional का topic है, population as a social capital. इस साल पूछा गया social capital क्या है. Fine. So don't think like GS का student. On the eastern part of the continents, the offshore westerlies gives rise to offshore westerlies brings cold ocean current to the surface. Labrador current, Oyashi current, giving rise to Laurentia type of climate. Giving rise to Laurentia type of climate. Laurentia type of climate, it's written there. Now remember, this is the westerly winds, onshore, offshore. Onshore warm ocean currents, and as a result of this, यहाँ पे होगा deciduous coniferous forest, because there will be rainfall also. So this will be broad-leafed coniferous forest or British type of climate. Unlike the tropical cyclones, temperate cyclones form throughout the year. Unlike the tropical cyclones, temperate cyclones form both on land and sea, and cyclone means rainfall or precipitation. So during the summer season rain, during the winter season snow, and as a result of this moisture is very high, and therefore interiors mein hai proper evergreen coniferous forest or taiga. Which is also known as boreal biome. यहाँ पे due to cold current, most of the time the ground is covered by snow, permafrost region type. There are trees, but there are lesser number of trees. Laurentia type of climate. See, because of the cold, have you finished drawing this? Can I continue? See, because of the cold ocean current here, summers are very short, winters are very long. Winters में it is mostly covered by ground, snow. Summers है ज़्यादा से ज़्यादा 35 to 40 days का, which is very less time for agriculture. And इसीलिए the most important occupation of the people here is fishing. And during the summers, cutting of tree, lumbering activity. Getting it? यहाँ पे एवरग्रीन कैसे, क्यों? ये तो सवाना जैसा होना चाहिए था, but because of cyclones. Summers आते ही snow will melt, it will give excess moisture to the ground, and therefore trees are evergreen throughout the year. The only thing is they are conical in shape, Christmas tree जैसे, so that they don't suffer from frost bite. What happened? Eastern coast of Canada, Newfoundland, Grand Banks region वो वाला, साइबेरिया, नॉर्वे, फिनलैंड वैसे तो पोलर रीजन्स में है, आर्कटिक सर्कल में, बट स्टिल बिकॉज ऑफ द वार्म ओशन करंट वहाँ पे स्नोफॉल कम है, इसलिए जंगल ज़्यादा है, इसलिए नॉर्वे इज़ फेमस फॉर लंबरिंग एक्टिविटी. ब्रॉड लीफ कॉनिफरस ट्रीज, ब्रॉड लीफ, उसको हम कहेंगे ब्रॉड लीफ कॉनिफरस. ब्रॉड लीफ इसलिए, मैपल ओक इसलिए बिकॉज रेनफॉल ज़्यादा है तो उनको इतना फ्रॉस्ट बाइट का टेंशन नहीं है, सो द लीफ इज बिट ब्रॉडर. कॉनिफरस या ब्रॉड लीफ टेम्परेट डेसिडियस फॉरेस्ट, कॉनिफरस अगर लिखना नहीं है. जहाँ पे रेनफॉल कम है इन द ताइगा रीजन, अंडरस्टैंड, जहाँ पे रेनफॉल कम है इन द ताइगा रीजन, सॉरी इन द दिस रीजन, वेस्टर्ली स्काई रीजन, थोड़ा नीचे के लैटिट्यूड्स में, वहाँ पे रेनफॉल कम है, हीट ज़्यादा है बिकॉज इट इज़ इन द लोअर लैटिट्यूड्स, सो इसलिए बिकॉज साइक्लोन्स ऊपर ज़्यादा बनेंगे, सो इसलिए यहाँ पे ट्रीज नहीं है, यहाँ पे ग्रास है. But how is the grass? Grass is very soft because comparatively the temperature is less. We'll call this as steppe biome. But ये सब आंसर में लिखने की ज़रूरत नहीं, एक बहुत है. Steppe biome and the taiga biome में differences of the latitudes. So because it is in the lower latitudes, there is lack of snowfall. Because it is in the higher latitudes, there is a snowfall. The snowfall is there, it melts and gives moisture, evergreen. Less snowfall, more evaporation, less moisture available, trees cannot grow and therefore grasses will grow. But the heat is not as great as tropics. And इसीलिए जहाँ पे heat बहुत ज़्यादा है, tree will try to conserve the moisture in the form उसको काटे होंगे. There will be thorns on the grasses, on the leaves. So जब thorns है, savanna. जब the grass is very soft, juicy, steppe. And therefore steppe is famous for agriculture. Prairies, steppes, pustas, downs, etc. Why agriculture? Because agriculture के लिए require cattle. And cattle can survive only in the soft grasses. Fine? On the thorny grasses, on the rough grasses, cattle नहीं होगा. Either there will be goat or antelope का population या deer का population. So savanna is famous for deer है, which cannot be domesticated, so it is wild. Lions है, tigers है. So savanna इसके नीचे is known as a big game country. इसके नीचे क्या है? savanna. उसके नीचे क्या है? tropical evergreen forest. Tropical evergreen 0 to 5 degree or 10 degree. 30 to 35 savanna. 35 to 45 steppe. 50 to 65 taiga. Above 65 tundra. Getting it? India में, because Himalayas are such of a highest mountains in the world, so at every 1 kilometer 6.5 degrees Celsius से the temperature changes. So on the foothills of the Himalayas, tropical evergreen. बीच में savanna हो सकता है या नहीं हो सकता, but steppe है. And the steppe grasslands in India are known as margs. Gulmarg, Sonmarg. Fine? उसके बाद taiga, evergreen coniferous forest, and उसके बाद tundra at the peak of the mountains. Snow leopard, clouded leopard, normal leopard or tiger. Getting it? I will not ask you to read polar winds from here because इतना ज़्यादा हमें लिखने की ज़रूरत नहीं. There will be no question on the polar winds. But polar winds मैं इसलिए आपको explain कर रहा हूँ because we should know what is the importance of cryosphere. Polar winds originate from the cryosphere. What is this cryosphere? Cryosphere is the region जहाँ पे the temperature is very, very cold. That is, these are the regions of ice caps, glaciers or the third pole regions. That is mountains जहाँ पे there is ice. Generally these polar winds are caused due to descending air. In the mountainous regions, if there is a mountain and if there is an ice cap, this wind comes downwards, which is extremely cold. And therefore, why? Because it is very dense. Cold polar air or the region's air in the cryosphere is very dense because of the cold. And वो नीचे आती है. कोई भी wind जब नीचे आती है, तो it is known as katabatic wind. Wind that comes down the slope under the influence of gravity is the katabatic wind. We have studied one katabatic wind. Valley breeze. We had studied one katabatic wind, valley breeze. If the wind that goes upwards, up the slope, it is known as anabatic wind. So polar winds are generally katabatic because they are so cold that they come downwards. Fine. What is the importance of or the significance of the polar winds? The significance of the polar winds is they bring the cold currents downwards, and when they bring the cold currents, this helps in meridional circulation and maintenance of the temperature in the atmosphere. This also helps in diffusion of salinity in the oceans, because cold water is always more denser and more saline. So it helps in diffusion of salinity. Connect it to the AMOC, current affairs. As the water is becoming more warmer, the cold currents will be impacted. There will be less cold currents, and because of this there will be less transfer of heat from or transfer of cold from polar regions to the equatorial regions. So in the future, maybe in 25-30 years, the temperature will go on increasing in the tropics and the temperature will go on decreasing in the poles, and thus there will be no latitudinal heat balance affecting the heat budget of the earth and giving rise to different types of climatic conditions. Maybe tropical cyclones will become very severe, droughts and floods will become very severe. Global warming, tell me if you understand, global warming will result into more rainfall or less rainfall? मतलब अगर रेनफॉल होनी है इंडिया में, इफ इट इज 186 सेंटीमीटर्स एवरेज एनुअल रेनफॉल, ग्लोबल वार्मिंग से ये बढ़ेगा या कम होगा? बढ़ेगा, बिकॉज there will be more evaporation, more loss of heat, more low pressure belt. But the only thing is the span, time, intensity, duration will be very erratic in nature. There may be a very heavy rainfall followed by long periods of dry days. And average rainfall will be more or less more than 186. Very heavy rainfall will result into formation of floods, and followed by the dry days it will result into droughts. So if there is no polar region, there will be no meridional exchange of heat or latitudinal exchange of heat, and thus it will give rise to extreme climatic conditions. So understanding, एक question है आपको, what is the impact of cryosphere on the global climate? Just open 2012 का paper. Give me. Answer the following: impact of the cryosphere on the global climate. Mila? Question number 39 in this booklet, 2012, question 3C. And the same question came in GS 2016 as it is. What is the importance of cryosphere on the global climate? So I have just told you one. Tell me the remaining impact. पोलर विंड्स नहीं है तो फ्रंट्स नहीं है, क्योंकि फ्रंट्स के लिए एक वेस्टर्लीज चाहिए और एक ईस्टर्लीज चाहिए. सो इफ द आइस विल स्टार्ट मेल्टिंग इन द पोलर रीजन्स, इट विल बिकम लेस, इट विल नो लॉन्गर रिमेन अ हाई प्रेशर. If it no longer remains a high pressure, fronts के लिए the most important condition is convergence of two temperature difference वाले air masses, that is two contrasting air masses. Westerlies ऊपर जाते जाते it becomes colder, and if it remains at the same temperature as polar easterlies, subpolar low pressure belt world में से गायब. If it goes no fronts, no cyclones, no cyclones, ये पूरा जो क्लाइमेटिक कंडीशंस है सब गए वर्ल्ड में से. नो ताइगा, नो एक्सेट्रा दिस रीजन. एंड थर्डली, वेस्टर्लीज ही है जो इंडिया में विंटर्स में रेनफॉल देती है, विच इज़ नोन एज वेस्टर्न डिस्टर्बेंसेस. आंसर बहुत लंबा होता, आई हैव नॉट मेड यू राइट, बिकॉज ये बाद में आपको याद हो जाएगा. ये जो विंटर रेनफॉल है, इट इज़ कॉज्ड बाय टेम्परेट साइक्लॉन्स विच आर ब्रॉट इन इंडिया बाय वेस्टर्ली विंड्स. फाइन. So winter rainfall even in the subtropical regions will get affected. And then बाकी का importance is General understanding climatology, albedo will decrease, there will be rise in the sea level, there will be warming of the oceans, salinity pattern will impact. So you are not I am not expecting you कि अभी solve करो, ये last में solve करना, because but ये दो points इसमें याद रखना, fine? That is fronts वाले and meridional heat exchange वाला point. Getting it? Polar winds. Thermally induced high pressure belt. Thermally induced high pressure belt. Is the reason for generation of the polar winds in the form of easterlies. Is the region for generation of the polar winds in the form of easterlies. Thus the polar winds originate from cold anticyclones. Originate from the cold anticyclones. Underline the word cold anticyclones. Cold anticyclones. They are more stronger over Antarctica than Arctic. Over Antarctica than Arctic. Why? Because Antarctic is landmass and landmass will get more cooler. Is Antarctica a continent or ice cap? Continent. Which is the deepest gorge in the world? Gorge or canyon in the world? Grand Canyon तो सिर्फ -86 मीटर है. It is just 86 meter deep. इंडो नेपाल बॉर्डर पे है काली गॉर्ज और शारदा रिवर का गॉर्ज. इट इज सेड टू बी द डीपेस्ट गॉर्ज इन द वर्ल्ड. जो यहाँ पे काला पानी रीजन है, जहाँ पे लिपुलेह पास है. काली रिवर इज नथिंग बट इन इंडिया दिस रिवर इज नोन एज शारदा, इन नेपाल दिस रिवर इज नोन एज काली. इतना इनएक्सेसिबल है ये दैट नोबडी कैन विजिट इट. सो टूरिज्म के लिए कौन सा फेमस हो गया? ग्रैंड कैनियन. फाइन. बट recent discoveries have shown that deepest gorge in the world is in Antarctica, buried under the thick ice. It is also said to be the longest gorge in the world. Remember, Antarctica don't go by the videos we have seen. Antarctica has mountains, plateaus, plains, just like anything. The only difference is some of this region is buried under ice. Right? Why I am telling you all this? Because now understand the statement I am dictating. Fold mountains है अंटार्कटिका में. Plates है ना, गोंडवाना पार्ट का ही तो है. So there are fold mountains. Understand the line I am dictating. Over the Antarctica, powerful katabatic winds. Obviously these winds are cold. Powerful katabatic winds move down the plateaus and mountains. Move down the plateaus and mountains. Giving rise to blizzards. Giving rise to blizzards. What are blizzards? Snow laden dusty wind. जैसे इंडिया में धूल होती है, dust particles, ये snow particles है, giving rise to blizzards. But हमें पता नहीं चलता. हम GS में करते हैं blizzards are present only in the northern. मैं GS में, if you remember what I teach, नॉर्थ अमेरिका का एक डायग्राम, रशिया का एक डायग्राम, दिस इज अ ब्लिजार्ड, दिस इज अ ब्लिजार्ड, दिस इज नोन एज नॉर्वेस्टर, नॉर्दर, एंड दिस इज नोन एज बुरान. बट पावरफुल ब्लिजार्ड्स आर प्रेजेंट इन अंटार्कटिका. किसी ने डाउट पूछा कि सर सदर्न हेमिस्फीयर में क्यों नहीं है, तो ही मैं एक्सप्लेन करता हूँ. किसी ने डाउट नहीं पूछा तो फाइन, देयर इज नो नीड फॉर सच थिंग्स. देन नेक्स्ट, such blizzards also occur over Arctic. Such blizzards also occur over Arctic during the winter season. During the winter season. And they cause cold waves. They cause cold waves. Or bomb cyclones. Cold waves or bomb cyclones. Bomb cyclones. Bomb cyclones. In the in North America, and Siberia, mostly in North America, and Siberia. क्यों North America में? Why this specifically is North America? Because North America is the only continent, you remember, Northern Hemisphere में only continent जिसमें East-West mountain barrier नहीं है, and therefore Alps East-West है, Himalayas East-West है, वहाँ पे Rockies are North-South. Because it is north and south mountain barrier, therefore Canada में से any cold wind which originates, it can come much to the south of southern part. India में या Europe में this is not the case, as we have the east-west mountain barrier. Fine. In North America, due to the lack of east-west mountain barrier. Due to the lack of mountain barrier. Similarly, the polar easterlies are responsible for development of cyclones. Similarly, the polar easterlies are responsible for the development of temperate cyclone, comma, polar front jet stream development of temperate cyclones, comma, polar front jet streams, full stop. पोलर फ्रंट जेट स्ट्रीम, जो कल मैंने ऊपर वाली जेट स्ट्रीम दिखाई थी, पोलर फ्रंट जेट स्ट्रीम. They also help in latitudinal heat balance. they also help in latitudinal heat balance through surface and halocline ocean circulation. Surface and halocline ocean circulation. Through surface and halocline ocean circulation. Circulation in the form of currents. That's it. So जो हमारा क्रायोस्फीयर का आंसर है, इट शुड बी टेक्निकल आंसर, एंड उसमें जेट स्ट्रीम्स का मेंशन होना ज़रूरी है, उसमें साइक्लोन्स का मेंशन होना ज़रूरी है, उसमें ये वर्ड्स होने ज़रूरी है, हेलोक्लाइन सर्कुलेशन. अदरवाइज 2015 में जीएस के बच्चों ने लिखा था अल्बिडो, वही सिर्फ दिमाग मत चलाओ. फाइन, बी बिट टेक्निकल इन योर आंसर. 2012 was my last attempt, and this was the only question which was properly and easiest. If you look in the proper question paper, इसके साथ साथ के बाकी के दो क्वेश्चंस काफ़ी आसान थे, and therefore I chose this. But me and many people in our class did not knew what is cryosphere. इससे पहले कभी ये वर्ड सुना ही नहीं था cryosphere. But फिर मेरे बाजू वाले की तरफ देखा मैंने, लड़की थी बैठी हुई, वो पेपर देख के रोने लग गई थी. इट वॉज वेरी टफ पेपर. फाइन, मतलब उसका पेपर भी चल रहा था और आंसू भी चल रहे थे. तो आगे मेरे जस्ट आगे मेरा फ्रेंड बैठा था, उसको नीचे से लात मारी, ये है क्या क्रायोस्फीयर? वो बोला नहीं पता. पीछे दीवार थी, तो कोई पूछ ही नहीं सकता था मैं किसी को. Fine. We already means we all friends used to fill the form together because तब इसमें आते थे. उससे काम ये आसान होता था, half of the map entries he used to know, half of the map entries I used to know, and then used to be exchange of the information. पढ़ेंगे कितने, दो ऑप्शनल कैसे कर पाएगा कोई in the short span of time. Then I read in Hindi, हिमस्थान का महत्व क्या है? Understanding? हिमस्थान के महत्व क्या है? Him means snow, स्थान means area. फिर दिमाग चला, अच्छा क्रायोजेनिक वाला होगा ऐसे, क्रायोस्फीयर. फिर तो रोका ही नहीं. राइट, कंटिन्यूसली वेंट ऑन राइटिंग. एंड बहुत सारे लोगों ने, मीन्स आई वॉज नॉट द ओनली वन, बहुत सारे लोगों ने इधर क्रायोजेनिक इंजन वाला ये लगाया दिमाग, या हिंदी में पढ़ा. दोज हु न्यू हिंदी दे read in Hindi. Those who didn't knew Hindi, they used the word cryo means what? अच्छा, cryo means cold, therefore cryogenic engine. मतलब एग्जाम में जाके ऐसा डरना नहीं चाहिए, बिकॉज उसी पेपर में था बॉस्चुंगन एंड हैडलहैंगन. उसी पेपर में था IGBP. What is the major work of? Write a short note on the major work taken by IGBP. We came home, googled, पहले मिला नहीं IGBP, फिर डाला IGBP geography, नहीं मिला, फिर डाला IGBP climate and geography, फिर मिला International Geosphere Biosphere प्रोग्राम. वो क्या वर्क करता है वेबसाइट भी नहीं बता पाई. सो हाउ विल बी एबल टू राइट इन? आई रोट एन आंसर इन सम डिफरेंट. मैंने क्या इंटरप्रेट किया आई डोंट नो. जी को मैं, आई को इंटरनेशनल कर पाया, जी को मैं ज्योग्राफी कर पाया, बी को आई डोंट रिमेंबर, बट वो ऑब्वियसली जीरो ही मिला होगा उसमें. स्टिल द मार्क्स वेर डिसेंट, मतलब ऐसे नहीं कि बहुत खराब मार्क्स थे उस साल. उस साल मेरा गेम किया, मीन्स यू नो, और पब्लिक एडमिनिस्ट्रेशन में, अदरवाइज तो सिलेक्शन था उस साल. ज्योग्राफी नेवर फेल्ड, मतलब जो आज कहते हैं. So now we come to the concept of humidity, then we will come to the concept of jet streams, etc. Because humidity say first we will understand what is atmospheric stability, instability, cloud formation का process, and then all the other things. बाकी के जो winds है वो बहुत आसान हो जाएंगे. So considering to what is humidity, humidity is the amount of moisture that is present in the air. First I will explain you this thing. Now, how is this amount of moisture present in the air is measured in 3 parameters. It is measured in the parameter 1 ki exactly how much is the moisture holding capacity of a parcel of air. How much moisture can it hold? Suppose if this is the parcel of air, how much moisture it can hold? 1 liter. So this is humidity capacity. Understanding? And because it can be measured, it is always expressed in the terms of unit grams per centimeter cube. Volume hai, it is always expressed in the unit of grams per centimeter cube. Now, amount of moisture that is present in this bottle depends upon the size of the bottle. And if I expand this bottle, uska moisture holding capacity will increase. So, expansion of anything is done generally by heating, and therefore you remember humidity capacity is directly proportional to temperature. Abhi kuch mat likho, abhi sirf samajh lo isko. Humidity capacity is always directly proportional to temperature. Greater the temperature, greater is the moisture that air can hold, and because the greater is the moisture that air can hold, less is the chance of precipitation. Because इस बॉटल में से पानी क्यों गिरेगा, इसमें तो इसकी तो मॉइस्चर है. Precipitation will occur only if the air becomes super saturated. Super saturated means when the humidity holding capacity will decrease. This is what is the super saturated air. उसके बाद if I still press it, then there will be rainfall. This is what is the moisture. Secondly, the second measure of the moisture is specific humidity. Specific humidity, specifically कितना पानी है इस parcel of air में. This is उसका capacity, but humidity is not same as the capacity. It is only 750 liters. Fine. So amount of moisture that is exactly present in the parcel of air, whatever the parcel of air we are going to study. It is also expressed in the terms of grams per centimeter cube. Fine. And ये पानी कितना है इसमें does not depend upon temperature. It depends upon potential evapotranspiration. And potential evapotranspiration does not just depend upon temperature, it depends upon numerous other factors. For example, कितना evaporation होगा, अभी तक हमें लगता है it depends upon temperature, that if the temperature is high, evaporation will be great or more. ऐसा कुछ नहीं है. If the temperature is very very high, but if the air is full of humidity, it does not have any space in the molecules to take excess moisture, and thus it will discourage evaporation. But if the air is dry, it may encourage evaporation. If the temperature is great, air is full of moisture, and if there is no wind, air usi jagah rahegi. But if there is high amount of wind, air will move from one place to another. When it goes to some other place, it may go on the land and give the rainfall, and thus it will empty the moisture to take more moisture. So specific heat kitna hai, or specific humidity, how much is there, kitna moisture is, it is an independent construct. Both of these parameters are of no use to us, but these parameters we study to understand the most important concept of moisture, that is relative humidity. Relative humidity is the most important parameter because rainfall will occur or not occur. How heavy or how less heavy the rainfall will occur is determined by climatologists with the help of a calculation, and this calculation is known as relative humidity. Relative humidity is always given as a ratio or a percentage, and the percentages specific or absolute humidity, कितना water vapor है air में, that is specific or absolute, upon humidity capacity into 100. Fine. For example, if the specific humidity is 5 grams and if the humidity capacity is 10 grams, how much is the relative humidity? It is 50%. Means air is only 50% full of humidity, therefore no rainfall. ऐसा नहीं कि there is 50% chance of rainfall. Rainfall will occur only if the relative humidity becomes more than 100%. If the relative humidity becomes 100%, condensation will start. What is the difference between condensation and precipitation? Condensation is cloud formation. When the clouds become very, very heavy, then they start falling down. That is precipitation. Understanding? So, but if you see the equation very properly, you will see humidity capacity, which is directly proportional to temperature, is in denominator. And therefore, you should understand that relative humidity is inversely proportional to temperature. मतलब रेनफॉल के चांसेस सबसे ज़्यादा होते हैं जब टेम्परेचर सबसे कम होता है. That is, therefore, you will see in your real life also, rain generally occurs in the early morning time या late evening या late night. भर दोपहर में 12 से 3 के बीच बहुत कम बार very heavy rainfall occurs because heat is more, air is in the expanded state. Fine? Because the air is in the expanded state, therefore it can hold more moisture. You see, mostly early morning या evening time, there is a chance of a rainfall. Relative humidity, because it is the relative humidity that determines the type and the kind of rainfall. Type of precipitation and the kind of precipitation. Type, snowfall, rainfall, hailstorm, drizzle. Kind, orographic, convectional or cyclonic. Understanding? Now, how can we increase or decrease this relative humidity? The increase or decrease of this relative humidity can be done on two parameters. Either increase the water vapor content, absolute humidity. So, if we increase the water vapor content, that means 10 हो गया 5 से, humidity capacity remains 10 into 100. So, relative humidity will become 100%. If I make it 20 upon 10 into 100, the relative humidity will become 200%. That is, इस bottle में से पानी गिराना है मुझे, तो I should fill in more water in this bottle. It's very easy here, but in real life, there is only one way of increasing the humidity is through the process of evaporation. So, whenever there is more evaporation, there is more heat, and because there is more heat, ये मीटर शुरू हो जाता है. अगर ये 10 हो गया, तो ये 15 हो जाएगा. ये अगर 20 हो गया, तो ये maybe 30 हो जाएगा. Understanding? More heat, more expansion of the air, and because more expansion of the air, ये equation कभी 100% बनेगा ही नहीं. Because if there is more evaporation, then there is more heating. More heating, what is directly proportional to the temperature? Humidity capacity, and humidity capacity of the air will go on expanding, and therefore summers में during the month of April and May in India, when the heat is so high and the evaporation is so high, कभी भी rainfall नहीं होता. Rainfall starts in the month of July, August, जब थोड़ा heat कम होना शुरू हो जाता है. In India, Kerala में rainfall comes in the month of June, but North India में it never starts. Delhi में the monsoon starts on 15th of July, because 21st of June को sun is exactly on vertically overhead, over the Tropic of Cancer. Understanding? So, the second way of increasing the relative humidity is decreasing the humidity capacity. Because humidity capacity is directly proportional to temperature, तो कैसे naturally decrease होगा humidity capacity? The humidity capacity will naturally decrease that if this is the parcel of air and if the humidity capacity is 10, this air due to heating will start rising upwards. As it starts rising upwards, uska temperature is going to decrease. And because uska temperature is going to decrease, uska humidity capacity is going to decrease. As the humidity capacity decreases, maybe the humidity capacity becomes 5 and therefore 100%. If due to heating, air still rises upwards, जहाँ पे जब ये 5 बनेगा, then it will result into formation of clouds. Understanding? And then if the air will still rise upwards, uska humidity capacity will still decrease, because as we go up, the temperature goes on decreasing at the rate of 6.5 degrees Celsius per kilometer. Fine? But this air, when it is rising upwards, जब तक उसका relative humidity has not become 100%, it will cool at dry adiabatic lapse rate. Understanding? That is 10 degrees Celsius for every kilometer. And once it forms 100% बन जाता है, remember I am taking 5 इसलिए because here 5 is our humidity capacity. It becomes 100%, it will start cooling at a lesser rate. And if it starts cooling, जैसे ऊपर हो रहा है, this is what is happening in the air. As it is rising upwards, it is cooling. I am taking general physics. Cooling मतलब contraction, but this is not happening here. उसका temperature is decreasing. So I am not adding any moisture to this. Still the water level is increasing. The point where the water level becomes 100% saturated air. If I still press it, precipitation. Right? So this is what is happening. Thus the precipitation always depends upon the rise and fall of air without the addition of moisture from outside, and therefore we say that it is adiabatic process. Adiabatic खुद से ही, just due to ascent or descent. On other hand, अगर air नीचे आ रहा है तो is it heating now? And इसीलिए descending air is always dry and ascending air is always moist or wet. अब air सिर्फ heating से ऊपर नहीं जा सकता. Air can go upwards heating even if there is a mountain barrier. Air को ऊपर नहीं जाना है, it is not heated, but it is forced to go upwards due to mountain barrier, and then it will start cooling. So this is the natural instability in the air. This is mechanical instability. This topic which we are going to do is basically nothing. Humidity के ये सिर्फ concepts पता होने चाहिए. कभी कभी क्वेश्चन आता है एग्जाम में, and it is very easy question. But basically इस टॉपिक का नाम है humidity, stability and instability. And if you see at the past year questions, ये है जो बहुत बार आता है. Potential evapotranspiration, stability of the atmosphere, instability of the atmosphere, etc. Getting it? Very good topic to understand. Have you understood this? Now, the point at which relative humidity becomes 100%, relative humidity has become 100% due to the adiabatic change, is known as the point of saturated air. Is what is known as unsaturated air. So air has become saturated. Air has become saturated at this height. It may be 1 kilometer, it may be 5 kilometers, it may be 10 kilometers, anything. It can be 0.5 kilometers also. Depend करता है already कितना moisture है air में from the ground. So the height at which the air becomes saturated, यहाँ पे there will be different temperature as compared to ground, right? At certain height there will be different temperature as compared to ground. So the height के ऊपर जो temperature है, so the temperature at which air becomes saturated, this temperature is known as a dew point. So the temperature at which air becomes saturated is known as dew point. It has nothing to do with the dew of temperature inversion. Fine, this is just a calculation के लिए dew point. क्या importance है dew point का? Dew point का importance है, it determines the form of the precipitation. For example, if the air becomes saturated at this height, this is my line जहाँ पे the temperature is 0 degree Celsius from the ground. If the air becomes saturated at this point somewhere from the ground, that is above 0 degree Celsius, plus, यहाँ पे there will be precipitation will be in the liquid form. हमें optional में rain नहीं लिखना है, हमें लिखना है precipitation will be in the liquid form. And if the dew point is below 0 degree Celsius, जितना greater height उतना greater chance है below 0 degree Celsius, the temperature will be in the form of snow or in the form of solid form. Getting it? So this is what is the concepts of humidity. So relative humidity is inversely proportional to temperature. So with this, tell me, relative humidity will be lowest in which part of the world? जहाँ पे highest heat है. Highest heat कहाँ पे? Temperature, relative humidity will be lowest in the which part of the world? 0 to 10 degree, 30 to 35 degree, 60 to 65 degree, 30 to 35 degree. That is the subtropical high pressure belt, जहाँ पे the air is forced to come down. Relative humidity, इसीलिए deserts वहाँ पे है. Understanding? Because the air is coming, relative humidity is also very less because the temperature is very high. Because relative humidity will determine the rainfall and precipitation. Getting it? Understanding this concept? This concept is very easy. Tough है stability and instability. Tough इसलिए because the same thing. It has many parameters: conditional, convectional, mechanical. Fine. Clear with this? So humidity. कल करे सो आज कर. क्या करोगे कल? कल आपको साइक्लोन्स में घुमाऊंगा. The atmospheric humidity is the amount of water vapor content of air at a certain temperature and a place. At certain temperature and a place. And a place. Because it depends upon the place. Underline the word water vapor. And at certain place. Place means height, certain temperature and certain place. फाइन। अब एक चीज याद रखना, वाटर वेपर इट डज नॉट मीन्स एनीथिंग, इट हैज नथिंग टू डू विथ कि अगर कोई एयर है उसमें वाटर ड्रॉपलेट्स है उसको हम ह्यूमिडिटी नहीं कहेंगे। इट इज ओनली वाटर वेपर, गैस इन द गैसियस फॉर्म, इन द फॉर्म ऑफ लेटेंट हीट। फाइन। सो जो आपके मोबाइल पे दिखता है XYZ है ह्यूमिडिटी, वो सब वो ह्यूमिडिटी नहीं है, दैट इज द अमाउंट ऑफ वाटर। वाटर है, वाटर वेपर है, स्नो पार्टिकल्स है, सब कुछ है। रिलेटिव ह्यूमिडिटी मेजर करने के लिए सोफिस्टिकेटेड इंस्ट्रूमेंट्स चाहिए। इट कैन बी मेजर, इट इज़ यूज्ड फॉर वेदर प्रेडिक्शन ईदर बाय स्काईमेट, वेदर चैनल या फिर द IMD। फाइन। सो नेक्स्ट पॉइंट, humidity does not describe the presence of liquid droplets of fog, cloud or rain. It does not describe the presence of liquid droplets of fog, cloud and rain. It does not describe the liquid droplets in the form of fogs, clouds or rain. Humidity is significant. Because daily weather changes as well as stability and instability of the atmosphere. Stability and instability of the atmosphere is determined by humidity. Humidity. Next point. The global meridional distribution. Of moisture exchange can be shown with the help of following diagram. Can be shown with the help of following diagram. Draw this diagram along with me. What is this envelope? Troposphere. ये क्या है? कन्वेक्शनल हीटिंग, इसलिए यहाँ पे क्लाउड आएगा क्यूमुलोनिम्बस कंपल्सरीली. ये इसको ऐसे बनाना है. Which shows nothing but convection. देखो, this is how convection is. अंडरस्टैंडिंग? ड्राई जोन, ड्राई जोन. बट इसका ड्राइनेस इतना मैटर नहीं करेगा क्योंकि यहाँ पे ह्यूमिडिटी, रिलेटिव ह्यूमिडिटी बहुत ज़्यादा होगी, दो इट इज़ वेरी ड्राई बिकॉज टेम्परेचर इज़ वेरी लेस. पोल्स पे रिलेटिव ह्यूमिडिटी इज़ वेरी हाई. वाई? बिकॉज रिलेटिव ह्यूमिडिटी इज इनवर्सली प्रोपोर्शनल टू टेम्परेचर. इवेपोरेशन. Can I continue? The the meridional means as per latitudes. It has nothing to do with meridians, मतलब longitudes. The meridional moisture exchange involves transfer of moisture. Moisture exchange involves transfer of moisture between the latitudes in the low pressure belts, इक्वेटोरियल या सब पोलर दोनों लो प्रेशर है. इन द लो प्रेशर बेल्ट्स precipitation exceeds evaporation precipitation exceeds evaporation. And therefore, these regions are humid zones. For these regions are humid zones. In this region, potential evaporation in these regions, the potential evaporation, sorry, I'm so sorry. In this region, the potential evapotranspiration, not evaporation, evapotranspiration. What is evapotranspiration? Not only just from the plant. Loss of moisture through soils, plants is what is known as evapotranspiration. Evaporation, evapotranspiration. Potential evapotranspiration is high. Potential evapotranspiration और evapotranspiration का कोई संबंध नहीं है. Potential evapotranspiration, I'll tell you tomorrow what it is high, which have been used by climatic models, to classify the world climates. In 4 or 5 lectures we'll do, after 4 lectures we'll do Trevartha, Köppen, etc. उसमें तो आपको समझ में आएगा what is this potential evapotranspiration. Climatic models to classify the world climates. Thornwhite जो मैं कहता हूँ is same like Penck. He has used the index of thermal efficiency, which is based on the calculation of potential evapotranspiration to classify the world into 140 different climatic zones. Fine? Next point. While in the regions of subsidence, evaporation exceeds precipitation. Exceeds precipitation. Clear? Resulting into formation of anticyclonic conditions. And dry air masses. We'll continue tomorrow then. Dry air masses and dry air masses. ठीक है?